Okay, so 6.1 is on power series. And functions. Okay, so a power series, okay, is a series, but it has a variable. It has a variable x. Okay, instead of and it also has a variable n, but there is a variable x in the series. Okay, so it's a function of x. Okay, n is just the index for the powers. Okay, so let's look at a power series. See how it's defined. Okay, if the power series is centered at 0, okay, then we have the following series. N equals 0 to infinity. They're going to start at 0, so keep that in mind. Before we started at 1, but now we're starting at 0 for our power series because we want to make sure that 1 is our first term. Okay, and this is going to have a constant, some constant, and each constant could be different, could be the same. But then we're going to have an x to the nth power. Okay, so this is going to go up by, the 0th power, which is 1, first power, which is x, second power, which is x squared, and x cubed, and so forth and so on. Okay, and so this is equal to c sub 0 plus c1 x plus c2x squared, okay, plus c3x cubed plus dot 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 plus cnxn plus dot dot dot. So it's just, I put in the nth term there. Okay, but it doesn't stop at n, it goes on to infinity. Okay, if it's centered at some value a other than 0, we have the summation n equals 0 to infinity of c sub n x minus a to the nth power now. Okay, and that's going to equal c sub 0 plus c1 times x minus a plus c2 times x minus a squared plus c3 times x minus a cubed plus dot dot dot. Okay, plus cn x minus a to the nth power plus dot dot dot. Goes on forever. Okay. Okay, the thing is that these theories will diverge if, for certain values of x. I plug in a value for x, say 1, okay, this thing's just going to continue to add on values and it's going to diverge. So we really want to know, well, the question, when is this thing going to converge? For what values of x will this thing converge? Okay. So okay, if I look at that question, for what values of x does the series summation n equals 0 to infinity of n factorial x to the nth. Now, the constant is now just n factorial. Okay, so when does this thing converge? And I'm going to use the ratio test to tell me when this thing is going to converge. Okay, the ratio test, okay, gives me a convergent series if the limit of the absolute values is less than 1. So I can use the ratio test, okay, to go, oh, this is absolute value a n plus 1 over a sub n, when is that less than 1? And when that's less than 1, I now know that it will converge, okay, for those values. Okay, so let's plug this in. I have the limit as n goes to infinity of n plus 1 factorial x to the n plus 1 all over n factorial x to the nth power. The n plus 1 factorial, that can be written as n plus 1 times n all the way down to 1. Okay, so n plus 1, n minus 1, dot, 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 all the way to 3, 2, 1. The n factorial is n minus 1, dot, 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 3, 2, 1. This x to the n plus 1 over x to the n, that just becomes x to the first, okay? So it kind of cancels. And so what we really are left with, okay, is these all cancel, 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 cancel. Okay, and we've got n plus 1 times x. Now, less than 1. Okay, so when does this thing converge? It really doesn't, because this thing, n plus 1, is going to infinity. Okay, that thing keeps getting bigger and bigger and bigger and bigger. And so I keep adding on bigger and bigger and bigger terms. The only time that this thing would converge is if x is 0. That's kind of the trivial case. So if x equals 0, then the series converges. Otherwise, it diverges. Okay. Okay, let's try one where it actually converges to something. Okay, it just doesn't diverge. Let's try a different one here. Okay, for what values does the series summation n equals 1, we're going to start at 1 this time, okay, to infinity of x minus 3 to the nth power all over n, when does this converge? Okay. Okay, so again, we're going to use the ratio test to help us out here. It's kind of the driving force to help us figure out when this thing converges. So I'm going to go x minus 3 to the n plus 1 all over n plus 1 all over x minus 3 to the nth all over n. Okay, this is going to be, we want to know when is that less than 1. Okay, so this becomes the limit as n goes to infinity of x minus 3 to the n plus 1 over n plus 1 times n over x minus 3 to the nth power. When is that less than 1? Okay, I'm going to simplify this. I'm going to write this as n over n plus 1 times. Now I've got an x minus 3 to the n plus 1 over x minus 3. That's going to simplify to just x minus 3. Okay, absolute value. Okay, so now what is the limit as n over 1 to n? Well, this thing goes to 1. Okay, if we take L'Hopital's rule on that, or if we even just divide top and bottom by n, we'll see that this limit basically goes to 1. Okay, as n goes to infinity. So we're really left with just the absolute value of x minus 3. is less than 1. So now I'm going to rewrite this, okay, and solve for x. So this is going to be -1 is less than x minus 3, which is less than 1. I'm going to add 3 to everything, and I'm going to get 2 is less than x, which is less than 4. Okay? And so we know that this thing converges, okay, for values between 2 and 4. However, we don't know anything about the endpoints. Okay, so is x equals 2, does that cause a convergent sequence or a convergent series? Or does 4 cause a convergent? I don't know anything about the endpoints. So what I'm going to do is I'm going to actually plug those back in. So plug into original and test. Okay, so let's plug this back into the original. Well, what was the original? The original was n equals 1 to infinity. Okay, x minus 3 to the n all over n. Does this thing converge or diverge when x is equal to 2? Okay, so let's let x equal 2. If x is equal to 2, we get n equals 1 to infinity of 2 minus 3 to the n over n. And this equals summation n equals 1 to infinity of -1 to the n all over n. And that is the alternating harmonic series. Does the alternating harmonic series converge or diverge? Is alternating harmonic. Does the alternating harmonic converge or diverge?
It diverges, right?
It actually converges
Oh, my bad.
by the alternating series test. So by the
Oh,
alternating series test, this actually converges. Okay, the alternating harmonic converges. So 2 is a part of what's called my interval of convergence. Okay, 2 is a part. Let's look at what happens when we plug in 4. N equals 1 to infinity of x minus 3 to the n over n. Let now x equal 4. And what do we get? We get n equals 1 to the infinity of 4 minus 3 to the nth over n, which is just 1 to the nth, which is just 1, which is just 1 over n. So, okay, this just becomes 1 over n, which is the harmonic series. And so the harmonic series, does that converge or diverge?
that's the one that diverges, right?
Yes, this is
Okay,
the
that's the
one
one I was
that
thinking of.
diverges. Yeah, this diverges, always diverges. Okay, the harmonic series diverges. So 4 is not a part, so we don't put an or equal to. It's just a strict inequality. And so my interval of convergence, okay, my interval of convergence goes from 2 is included, to 4, but 4 is excluded. Okay, so if I get values of x between 2 and 4, then I know that this series converges. Otherwise, it diverges. Okay. Okay, let's try another one. Number 3 here. Find the domain Okay, that means all the x values that work, okay, or basically the interval of convergence, okay, or what values will give me a convergent series. Find the domain, okay, for n equals 0 to infinity of -1 to the nth, so this is an alternating series, x to the 2nth all over 2 to the 2nth times n factorial squared. Well, that's a big one. Okay, find the domain for that guy. Okay, so we want to know for what values of x is this thing gonna converge? Otherwise, it diverges. Okay. Okay, so let's again use the ratio test to help us out. We want to know when does this thing absolutely converge? Okay, and so we're going to get -1 to the n plus 1, x to the 2n plus 1. Whoops, that should be in parentheses. Okay, all over, okay, 2 to the 2n plus 1. Okay, and then n plus 1 factorial. Okay, all over -1 to the n. Okay, and then x to the 2n all over 2 to the 2n all over n factorial. Okay, when is that less than 1?
Professor,
Yeah,
what happens to the square root?
square root. There's no square root.
Can you hear me, Professor? I think he's still muted.
Okay, no square root.
And I mean, I'm not square root, squared in the n factorial.
Oh, thank you. Thank you. Yes. Okay, thank you. Yes. Okay. Squared, perfect. Okay, thank you. Yes, I did drop that. Okay, so we're gonna have that squared. Okay, so now we have the limit as n goes to infinity of, okay, -1 to the n plus 1, x to the 2 times n plus 1. I'm gonna make this 2n plus 2. Okay, all over 2 to the 2n plus 2, n plus 1 factorial, okay, and then squared times, now the bottom gets flipped upside down. So this is going to become 2 to the 2n, n factorial squared, all over -1 to the nth times x to the 2n. Okay, now I might want to organize this so that you know, I have kind of like expressions over like expressions. So I kind of take them one at a time. So I'm gonna put like expressions over like expressions. So I'm gonna have -1 over n plus 1, -1 to the n. I'm gonna have x to the 2n plus 2 over x to the 2n. Okay, I'm gonna have 2 to the 2n over 2 to the 2n plus 2. 2 to the 2n plus 2, 2n plus 2. Okay, and then we're going to have the n factorial squared over n plus 1 factorial squared. Okay, this is less than 1, this is less than 1. Okay, let's take the -1 first. Again, if we have something to the n plus 1 over n, I just subtract those, and that cancel. I'm just left with a -1. X to the n, 2n plus 2 over x to 2n, subtract that, the 2n's go away, and I'm just left with x squared. Okay, this 2n, 2 to the 2n, again, same thing, that becomes 2 squared. Okay, and then the factorials, I can actually write as, because since they're both being squared, I can write as n factorial over n plus 1 factorial squared. Okay, that limit is as n goes to infinity. Okay, and so we have a -1/4 x squared, and then we have this n over n plus 1 squared. Okay, so if I kind of take this individually, the x squared, that's always positive. If I take the absolute value of -1/4, that's just 1/4, so I get basically an x squared over 4. And then I get this absolute value of n over n plus 1 squared is less than 1. That's an x, by the way. X squared. Because again, x, the absolute value of x squared is just x squared. Okay, and so I can kind of remove the absolute value. I'll do it like this, x squared, and then the absolute value of n over n plus 1 squared. Okay, I could pretty much drop the absolute value at this point. Okay, because anything squared is positive. Okay, and so now this just becomes the limit as n goes to infinity. Well, what is the limit of as n goes to infinity? Oh, you know what? It's not n. I'm so sorry. This is 1 over n squared. Okay, so this becomes 1 over n squared. Okay, because the n cancels out with the n plus 1. Okay, so this is, the only thing that survives there is the n plus 1. Okay, if I kind of wrote that out. Okay, maybe I'll write it out. This should be n times n minus 1 times n minus 2 dot 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 3, 2, 1 all over n plus 1 times n minus 1 n minus 2 dot 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 3, 2, 1. Okay, all of that is being squared. Okay, and so we get n over n minus 1, everything cancels except for the 1 over n plus 1. Okay, so the limit as of 1 over n plus 1, that goes to 0. So everything gets wiped out here. So x squared over 4 times 0 is just 0. So it didn't matter what x was. This will always converge. No matter what you plug in for x, it will always converge. So my interval of convergence is -infinity to infinity. So this is the domain, or what we call the interval of convergence. Domain of x. Okay, so -infinity to infinity. Okay, since x cancels out, okay, the convergence is not dependent upon x, so this converges for all x. Since x cancels out, convergence is not dependent upon x. On the values of x. So this converges for all x. That is, the domain is negative infinity to infinity. Okay. Okay, let's cover a theorem here. Okay, so theorem. Okay, for a given power series, okay, summation n equals 0 to infinity of c sub n x minus a to the nth power. Okay, there are only three possibilities. Okay, for any given, I'll put any there. Okay, for any given power series, there are only three possibilities. One, the series converges only when x equals a. That just means it goes to 0. Everything, all you're doing is adding zeros, it converges to 0. Okay, this is kind of the trivial case. Okay, number two, the series is not dependent upon x. Okay, the series converges for all x. Okay, negative infinity to infinity. Okay, and we saw that in example 3. Okay, or it's more like example 2, where the series converges when the absolute value of x minus a is less than r. Okay, and diverges okay, for absolute value of x minus a is greater than r. Okay, where r is referred to as the radius of convergence. Okay, now, this doesn't tell me anything about the endpoints, okay, or the interval of convergence. This is just telling me, hey, if you get it to absolute value x minus a less than some number, okay, then your radius of convergence is r. So if you kind of think about this, okay, you have a value x minus a, okay, and then you have a plus r and a minus r, okay, that's going to go down to, okay, for a negative r and a positive r, x minus a could have been, you know, is less than negative r, or x minus a could be less than positive r. And so you get kind of this, they call it a radius of convergence. It's a one-dimensional you know, distance, but they think of it as like, you know, this being a circle. Okay, and say, well, that's the radius of convergence. This is the radius of convergence. Again, it doesn't tell us any information about the endpoints. I'm doing this upside down. Okay, this doesn't tell us anything about these endpoints. So we still have to test the endpoints. Okay, to see if they converge or diverge. But anything inside that circle converges. Anything outside that circle diverges. Okay, the endpoints we still have to test. Okay, let's do one last example for 6.1. Okay, for find the radius of convergence and the interval of convergence okay, also AKA the domain of X, okay, for the power series okay, summation n equals 0 to infinity of -3 to the nth power x to the nth all over the square root of n plus 1. Okay, so we want to find the radius of convergence and the interval of convergence. Okay, so to find the interval of convergence, we have to test the endpoints. Okay, so let's take the limit as n goes to infinity of, okay, -3 to the n plus 1, x to the n plus 1, all over the square root of n plus 1 plus 1, all over -3 to the nth, x to the nth, all over the square root of n plus 1. Okay, and we want to know when is that less than 1. Okay, so again, we're going to flip the denominator. So limit as n goes to infinity of -3 to the n plus 1, x to the n plus 1, all over the square root of n plus 2, times the square root of n plus 1, all over -3 to the n, x to the n. When is that less than 1? Okay, let's kind of group like things together. The limit as n goes to infinity, I'm going to put the n things in first. Okay, where it's just dependent upon n. So this is the square root of n plus 1 over the square root of n plus 2. This is going to be times -3 to the n plus 1 all over -3 to the nth. This is going to become x to the n plus 1 all over x to the nth. When is that less than 1? Okay, let's take the limit as n goes to infinity of, let's simplify this. Since the top and the bottom are both being raised to the same power or square rooted here, I can square root the whole thing, n plus 1 over n plus 2. This is going to give me a -3, n minus n, that just gives me a -3 to the first power. And then same thing here, that's just going to give me an x to the first power, so that's a -3x is less than 1. Okay, now let's take our limit, okay? Yeah, I mean, I can separate this if I really want to. Absolute value of the square root of n plus 1 over, or sorry, square root of n plus 1 over n plus 2, okay, times the absolute value of -3 times the absolute value of x is less than 1. I can break it up like that if I really wanted to. Okay, but here, if you could see, like, if I were to divide both top and bottom, okay, here by, what would I want? A 1 over n squared. Okay, is that right? Yeah, 1 over n squared. If I divide both top and bottom by 1 over n squared, okay, or really the square root of 1 over n squared, let's do that. Okay. Let's put a big square root over that. Okay, that's still 1. Okay, but then I multiply that times n plus 1. over n plus 2 square root. This is going to become 3x is less than 1, or 3 absolute value of x, I should say. Okay, is less than 1. The limit as n goes to infinity. Okay, I'm going to bring I'm going to multiply these two square roots together. Since they're both being square rooted, I can just put them all under one square root. So this becomes the square root of n plus 1. Is that what I want? No, it's not. Get rid of this. Get rid of the squareds. Okay, I just want the n's. My bad. Okay, and so this becomes n plus 1 over n, all over n plus 2 over n. Okay, absolute value, 3 absolute value of x is less than 1. Limit n goes to infinity. Okay, so this becomes 1 over n, or sorry, so 1 plus 1 over n, all over 1 plus 2 over n, square root, absolute value, 3 times the absolute value of x. Okay, and now when I take the limit of this, I can take the limit of this. This goes to 0. This goes to 0. I get 1 plus 0 over 1 plus 0. That's the square root of 1. The whole thing just goes to 1. Okay, 1 times 3 times the absolute value of x is less than 1. 1 times 3 is 3. Absolute value of x is absolute value of x divided by 3. And I get the absolute value of x is less than 1/3. Okay, so what does that tell me? That tells me that the radius of convergence is equal to 1/3. Okay, what we would call r is equal to 1/3. Okay, the radius of convergence is 1/3. Okay, so by taking that limit, we got everything to be 1, and we divided by the 3 because the absolute value of 3 is 3. Absolute value of -3 is 3. And we get the radius of convergence. Now I need to get the interval of convergence. The interval of convergence means that I have to test the endpoints. Okay, so what is the interval that I'm looking at? Well, the absolute value of x is less than 1/3 means that I'm looking at values -1/3 to 1/3. Okay, that's the beginning of my interval. But what about the endpoints? We have to test the endpoints. Okay, so let's plug this in. If x equals -1/3, then I get the summation n equals 0 to infinity of -3 to the nth times x to the nth. But what is x? X is -1/3 to the nth all over the square root of n plus 1. Okay. Okay, and so this is equal to -3 times -1/3 all raised to the nth power all over the square root of n plus 1, summation n equals 1 to 0, n equals 1 to infinity. This is going to be -3 times -1/3. That's just 1. This is 1 to the nth over, put the limit in there. Oh, no, not the limit, the summation. N equals 0 to infinity of 1 to the nth all over, I'm going to write this as n plus 1 to the 1/2. Okay, and so this 1 to the nth, that just becomes 1. So what we're really asking ourselves is, does this series converge or diverge? Which is 1 over n plus 1 to the 1/2 power. Okay. And so what I can do is I can do a limit comparison to just n to the 1/2 power. Okay, so if we did a limit comparison with n equals 0 to infinity of 1 over n to the 1/2 power, what do I know about 1 over n to the 1/2 power? Does that converge or diverge? Does this thing converge or diverge? N to the 1/2 power. I'll give you a hint. This is a p series of 1/2.
Diverge?
It diverges. Thank you, Christina. Yeah, this diverges because it is a p series where p is less than p is less than or equal to 1. Okay, and so if p is less than or equal to 1, then this thing diverges. So we know this diverges. So let's do limit comparison. Let's find the limit as n goes to infinity of, okay, 1 over n plus 1 to the 1/2 over 1 over n to the 1/2. Okay, this is going to be equal to the limit as n goes to infinity of n to the 1/2. Sorry about my handwriting. Oops, n to the 1/2. All over n plus 1 to the 1/2. Okay, this I can rewrite as the limit as n goes to infinity of n over n plus 1 all to the 1/2. And so again, what is this going to go to? This is going to go to 1. Okay, again, I could multiply both top and bottom by 1 over n to the 1/2 all over 1 over n to the 1/2. Okay, and I could bring that inside. Okay, and so I get 1, I get n to the 1/2 over n to the 1/2 all over, okay, n plus 1 to the 1/2 over n to the 1/2. Okay, this all becomes 1. This becomes equals the limit as n goes to infinity. The top becomes 1. The bottom becomes n plus 1 over n to the 1/2. Okay. Did that really help? I guess it did, yeah, because then I could get 1 over 1 plus 1 over n to the 1/2. Now we take the limit as n goes to infinity. And so this now goes to 0. 1 over n goes to 0, 1 over infinity. And so then I get 1 to the 1/2 over 1. That just becomes 1, which is a constant greater than 0. Okay, so we get a constant greater than 0. And so therefore this converges by the limit comparison test. So negative 1/3, when x equals negative 1/3, this diverges, I should say. This diverges by the limit comparison test because the series that I compared against also diverge. Limit comparison test. So x equals negative 3 is not a part of the domain, not in the domain. Okay, so that's good to know. Okay, what about x equals 1/3? Let's test equals 1/3 now. Okay. Okay, we have the summation n equals 0, oops, n equals 0 to infinity of -3 to the nth times 1/3 this time to the nth, all over the square root of n plus 1. Okay, this is going to be equal to -3 times 1/3 to the nth power, all over the square root of n plus 1, n equals 0 to infinity. Okay, this is -1 to the nth power, all over the square root of n plus 1, n equals 0 to infinity. And that is an alternating series. Okay, so we're going to say, let's look at the alternating series test. Okay, for this guy, we have two criteria that we want to know. One is, does 1 over, or does bn plus 1, is that less than b sub n? Okay, so we're going to say, is 1 over the square root of n plus 1 plus 1, is that less than 1 over the square root of n plus 1? Okay, and I can just kind of see that, let's cross multiply this. This is the square root of n plus 1. Is that less than the square root of n plus 2? Yes. Okay, that does check. Number 2, is the limit as n goes to infinity of 1 over the square root of n plus 1, does that go to 0? And as you can see, this is going to be 1 over infinity, which does go to 0, so that checks. So so this converges. Okay, so x equals 1/3 converges by the alternating series test. And so x equals 1/3 is a part of the domain, is in the domain. So what does this tell me? This tells me that -1/3 is not a part of the domain, but 1/3 is in the domain. And so the interval of convergence is -1/3, not a part, 1/3 is a part. And so we can say that the interval of convergence, if we wanted to put this in interval notation, is -1/3 not included, 1/3 is included. Okay, and that is 6.1.